So it is Tuesday. Happy Garbage Day to all of you who celebrate. My neighbor's cans were starting to tip over and roll into the street when I took them back in. So if you have cans outside, don't forget about those. They'll be in someone else's yard by the end of the day. It's going to be one of those fun weather days. Let's see. Homework 3 was due yesterday. As predicted, not everyone has finished, so I can't go over any questions as a group. But if you have questions about what you missed or why, I'm happy to talk with you individually, or you can send those over email. I did update grades this morning. Next item up is project outline revisions, if those are needed. So I withheld 1 or 2 points from those for whom I need more information to be able to help guide you as to what you're going to do. But the idea is that I want us to have at least some level of written agreement in terms of what you're planning, and that way I know what to expect. That being said, you don't have to figure everything out on your own for your projects. So I did post the rubric for those, as well as the peer review template. Nobody wanted to change their dates, so the schedule is as it is going to be. If you want to talk strategy about what to present or what to emphasize, I would be happy to do that. But let me open up the rubric real quick for that so you can see the point totals. I had accidentally posted the wrong one at first and then fixed it right afterwards, so hopefully you have the right version. Let me grab this. Come on. There we go. Let me move this over to this window so we can see. So the idea is that we will have 15 to 17 minutes for each of your presentations and then 6 to 8 minutes for questions. So each 2 to 3 presentations on a day, up to 24 points towards your final grade. And if you look through the sections here and the relative point totals, that should give you some indication as to what you should prioritize. So this is a very different type of presentation than I think you would typically give at a conference. At most conferences, you would focus a lot more on the substantive message that you're trying to convey, summarize your analyses quite greatly just to answer your questions, and then focus on the implications. Here, given that our purpose is to expose each of you to more practice, essentially in figuring out what these models look like and how to use them, I'm asking you to do the opposite. So just enough information for us to understand the context and your questions, enough information for us to understand your data, and then the bulk of your effort should be in conducting and describing your analyses. So whereas in a typical presentation you would kind of skip to the end and get to like the take-home message, what I'm hoping that you'll be able to convey is your process. So especially if you started down one road and realized it wasn't going to work, like how did you learn that? What did you do instead? What blind alleys did you go down and then ended up coming back? Those kinds of things can be informative for those of us who are still trying to figure out what this stuff looks like. So the things in here then, trying to work our way from the data description all the way up to the main story. These are summarized in a general enough way that hopefully you can see in terms of what your study would be doing, how this would fit in here. But if you're not sure what you should present, please ask me. I'm happy to weigh in. I'm happy to have a conversation with you. I don't ever need to see your data if you want to send me code and outputs, because I know for some of you, you would have to get IRB approval or other kinds of approvals. I don't need to have access to the data. So, but if you want to send me data for something, that's okay, but just to keep that on the up and up here. Conclusions, and then, so relatively more points for aesthetics and presentation style. Now, this holds as a concept no matter what you're presenting about and to whom. So I'm looking for good visuals, good use of language, not like slides covered in words, slides covered in tables with numbers in 8-point font. That's one of my pet peeves at conferences, when people put up tables full of 8-point font and they say, I know there's a lot here, but just look at this one number. It's like, then why didn't you put the one number up there for us to look at? Like, come on, dude. Like, don't overwhelm your audience on purpose. Be cognizant of it and apologize. Fix it. So I get a little, what's the word I want? I don't know. A little upset when I see that kind of thing. I will give you warnings. So I'll give you like a 5-minute warning, a 1-minute warning, like they typically do in presentations. And I will cut you off if you go over. I will be that person, because that's one of the most important things, is to hit your time, no matter what it is. I will not, if someone goes over though, I won't let it cut into other people's time. There should be enough of a buffer to where that's not going to happen. I have seen that in real symposia at conferences though, where there's like supposed to be 5 talks in an hour, and by the time you get to the 5th, they have 3 minutes because everyone else went over their time. Like, that's never cool to be that person on either side of that equation. So This is your rubric. Let me know if I can guide you or offer advice if you get stuck on things, if models don't converge, if you want to deviate from your plan because things are not working. These are conversations we can have, all right? Agreement on that? Okay, so you can start letting this percolate. And peer review template is also up here. I'm asking you to send those both to me and to the person you're reviewing. Try to be constructive, but also helpful. So basic questions, what did you learn? What did you like about it? What suggestions do you have for the future? That kind of thing. All right, so any questions on presentations and all that stuff and the schedule for the rest of the semester here? We're good? All right, well, if anything comes up, let me know. Otherwise, we can head back to purple and green land. Not meant to be a joke, but, you know, I'm not trying to take over Greenland. I'm just using green and purple as contrasting colors. Question? No? Joke?
I just had a question about how disruptive my lunching was.
Oh, your lunching is not disruptive, at least to me. It's fine.
Okay.
Just don't spill on the laptops and get me in trouble. That would be the only disruption.
I will not do that.
Yeah, well, it's like I'm having class at 12:30. Like that's lunchtime. I understand that. But I had to pick the blocks that work with the regular classroom schedules, otherwise it all gets haywire. And if I pick the 3:30 to 4:45 block, then not only does everyone hate me, but then I'm probably going to be late to pick up my kid. So, because getting off campus at 4:45 is quite challenging. So I'm compromising and I'm allowing you to eat or drink or do whatever you need to do. It's fine. I don't care. I just care that you're here and that you're active and participating. So, all right, so we're talking about purple and green. What am I looking at here? Who wants to give my slide to me? We'll do review questions from a different perspective. That's my prompt. Who wants to give this slide to me? What's this slide about? Go for it. Yeah, half hand, go for it. Kendall's going to try.
This was for univariate software, so you had to partition the level 1 and level 2 variants.
Yep. We're using univariate software, partitioning into level 2 and level 1, our predictors. Yep.
And so you have to kind of create those like hard bounds, and then the Y can determine its own, like, partition its own variants.
Yeah, the model figures out how much of Y should be level 2 and level 1 as variance components, whose variances are estimated as part of the system. Yeah. So circles mean model figures out what these variables are. Boxes mean we make them manually ourselves. Yep. And in what kind of longitudinal data would this be a reasonable thing to do?
Longitudinal data with fluctuation as opposed to true change.
Yeah, fluctuation kinds of stuff, because time isn't in the picture. So if I'm just looking at like how grumpy I am today predicts how crappy I feel tomorrow kinds of things, where things just sort of bump up and down, but they don't change systematically, this would be appropriate. Let's see. What about this picture? Zoomers, you can play too. Who wants to walk me through this picture? I'm going to pick on the Zoomers here. What's different?
We have some circles instead of squares.
Yeah, so what does that mean?
It means that they're latent variables.
Indeed. Ahmed, you were going to say?
No, I wanted to say the same, actually.
You're going to say the same? I'm sorry, I still keep putting the C in your name. I'm working on it, I swear. I know there's no C, but I just keep putting it in there. You can call me Lisa to get even with me if you want, because there's no Z in my name, but people put one in all the time. Yeah, when they see the E, they automatically switch to Lisa. And then they throw an extra E in there for good measure, usually, too. So there was a talk show host whose name was Leeza. I think that may be where it came from. Anyway, that's what you're going to say, latent variables? Yeah, that's what I would say, too. So the idea here is that this is a multivariate model in which we're predicting X as an outcome and Y as an outcome simultaneously. And if we do this in multivariate software, meaning multi-level structural equation modeling software or single-level structural equation modeling software, any kind of package where you can predict more than one column of your data at the same time, then we can have relationships between X and Y be directed paths like this, so slopes, fixed effects, They can be covariances instead. They can be whatever they need to be. And this model then, for what kind of longitudinal data would this model be appropriate?
There's some sort of systematic change. Or is that later?
Do you see time in the picture yet?
Yeah, there's no time.
There's not time in the picture yet, yeah. So this would still be appropriate for fluctuation. The difference is that then we're treating X and Y in a parallel fashion, so that we're not pretending that our person mean, for instance, is perfectly observed, reliable, 100% reliable. We're letting it understand that, yeah, there's going to be some error to this estimation, and that is a consequence of having a different amount of data per person potentially, as well as extreme values. So shrinkage will happen as a result of those two things as well. So yeah, we want to grow this picture to accommodate time if needed, right? And up to this point, we'll go back to the X picture here, we could have added another green circle for change over time on the Y side, right? But there's no way to make an equivalent box over here for change over time in X. And so that's really the motivation for switching to a multivariate model where X can be an outcome, Y can be an outcome, and you can have multiple of those too. So I know 2 is the simplest case. Some of you are going to have 3 or 4 even. Right, Riley? I'm trying to talk her off the edge. She's like, I have a 7. Like, no, you don't. You have 3. Pick some. Because if you can get 2 or 3 going at the same time, you can get 7 going eventually too. But, you know. Yes, part of my job is always to make people do less than what they were planning, because it gets big real quick. But 2 at a time is what we're talking about here. So we started talking about this a little bit last time. Should we go back over some of these ideas in terms of extending the model into multivariate space? Maybe? We're feeling good? Are we feeling okay without that? Okay. So a couple things to think about. Let me jump in here. This is slide 9. So if your time-varying predictor, your X in the story, has individual differences in change, that's where you really can't do person mean centering as a choice anymore, because we have to be able to isolate 2 different kinds of between-person information in intercept and in change over time. And change over time could be multiple things, right? You could have linear and quadratic, or you could have before period and after period in a piecewise design, something like that. So the 2 concerns then, if people change differently, then non-parallel lines are going to cross and they're going to reorder themselves over time. So what we were thinking about is between, as like people who are higher on this on average, like that's no longer an adequate way to talk about it, because people who are higher depends on when you're talking about in these lines cross. So intercept would have to be much more specific, not just mean over time, but at 12 or at 18 or at 15 or whatever you have here. So that's one issue. So to solve that, we can potentially have change factors introduced into the model for both X and Y. So that'll be example 5B. We're doing just the fluctuation part to begin with that. All right. I think actually I might want to just do that. Do you want to see example 5A? It's based on this sort of idea with 3 things before we get into the change stuff. That's how I had sort of designed it in my head. Okay, let's do that. I'm going to open example 5A. This one is one that you do have the data for it, because this is from chapter 8 of the textbook. And we're going to be using M+ for this, which is why the handout is in landscape, so I can try to get output and syntax all on the same page here. So I have a lot of words. I'm not going to read these to you because you can read, but these are all the caveats and discussion points as to what informed my process here. So I have 3 variables in my story. Each of these is measured on a daily basis for, I believe, 5 occasions. I threw out the first one and used the other 5. So first, when people fill out these kinds of surveys on the first day, they tend to be more reactive. And so that initial sort of, like, not really a retest effect, but an initial testing effect, people often throw away the first day of data in the daily diary to try to eliminate that process. But what I have here is a binary variable at level 1. It's in a box, so that means it's being treated as an observed variable. And it is whether or not a stressor was experienced on each of the days. So that's going to be my X in the story. The next variable is a rating of one's negative mood that day. That's going to be my mediator. So I have XTI and then I have ETIM here because these are circles. So the mediator needs to be an outcome of stressors as the X. Simultaneously, my mediator of negative mood is going to predict physical symptoms. So this is also a daily variable that's going to be an outcome. So to fit this model, I can't really use univariate software because negative mood needs to be both a predictor column and an outcome column at the same time. And so that's where the process starts to break down. There are ways to trick univariate software into doing this kind of model, but only at level 1. You can't get the level 2 part to work very well. So I'm not going to show you that. But I have various versions of this idea here, but this is the story. If you have a stressor happen to you, that makes you grumpy and that makes you feel worse. That's at level 1. At level 2, people who report more stressors than other people may report worse negative mood than other people and report worse health than other people as well. So the level 2 section of the diagram is people who, or more than other people, as what being higher on each of these variables means. Level 1 then is within persons on a day-to-day basis. If I happen to have a stressor today, how does that affect my negative mood relative to my typical level? How does that affect my symptoms relative to my typical level as well? All right, so I am making a choice to treat stressors as observed because it is a binary variable and it's a predictor. Currently in M+, there is no direct way to bring a predictor into the likelihood and give it a link function. It has to be predicted by something. So there is a way to do it if you go to single level structural equation modeling, so I'll show you an equivalent version of these models using that so that we have that option as well. And there's all the original syntax and output for each of the permutations online so that you have an example of each kind for you to work with and work from. So there's going to be, like, this is the story. You would think that this is relatively straightforward. It's not. It's not going to be. So that's my job, is to make sure that you understand all of the nuance that's involved in this and the ways that these paths can potentially be misconstrued or misinterpreted. It's a good time. All right. So first things first, we're going to do this in pieces. We're going to do X to M at the between level and the within level. That's the first piece here. So I'm going to break it into pieces and then put the whole thing together as a pedagogy, but also to try and examine like what pathways would be conducive to even asking mediation kinds of questions in the first place. So the first step then can be done in univariate software like Stata Mixed or R-Elmer or in M+. So these are likelihood equivalent. They should be pretty much the exact same set of results. So in M+, I am using the MSEM version of it where we have an explicit between and within. That means that we're using stacked data where it's 1 row per day per person. So the same data structure is happening for all of this. So if we start with the Stata, I have covariates of binary gender and age centered at 80. Then I have stressor as the original binary level 1 variable. And I have person mean stressors, which is centered at 0.4. So this would mean our reference person experienced stressors on 2 out of the 5 days. That's near the average, and so I picked that as a convenient reference point. I'm also adding in an interaction of gender by age as something that would predict symptoms. The effect of age tends to be a little bit stronger in women, as I recall, in this particular data set. It is real data, but it's been doctored a little bit to make the story, a little more interesting. In Elmer, same thing here. We're predicting symptoms. So this is X. Oh, I take that back. X to Y. I lied. We're not doing X to M yet. We're doing X to Y. There we go. Symptoms. Got it. My words are wrong. My letters are correct. So there you go. The usual process in Elmer here, I'm also asking for a linear combination. Because if you put in a variable that's been constant centered or uncentered, like this, what happens at level 2 changes, right? We don't have a between effect at level 2, we have a contextual effect. So that's what we're going to get out of this analysis. Therefore, to get the corresponding between effect, I add within and contextual together. So there's the lincom that would do that in Stata. Here is the Contest 1D version of it in our Elmer. And then we can head over to the M+ side and see what that would look like over here. So we're using maximum likelihood on stacked data. We're examining how observed stressors predicts latent physical symptoms as the Y outcome. Questions so far on the story or the setup?
Wait, so we automatically calculated the total effect, the total between person?
I am asking for that to be a linear combination of within plus contextual in each of the software packages, including in M+. Yep. And note, I had to change the names of the variables. So in M+, PM stress 40 is PM STR 40. Any guesses as to why I had to do that? Yeah, it
The
only,
characters.
8 characters. 8 characters or fewer, that's why. Welcome back to 1985, folks. That's how it used to be in all the packages. And stress became stressor for the same reason, just to keep it short. Okay, let me dial in here. I'm guessing that a lot of you are going to end up using M+ or some R analog to this, so I want to spend a little bit of time making sure that you understand the codes and what is being asked for. So title is optional, that's just for your results. File, it wants to know where your text data file is. So there's no path needed if it's in the same spot as the input that this would be in. You do need a path if it's someplace else. And CSV is the format that I recommend because when you double click on it, it usually opens nicely in Excel or whatever spreadsheet package you have. It makes it easier to read to make sure that it looks okay rather than delimited data or something like that. Names. The names of all the columns in your data in order. So I would recommend cutting your data set down to just what you need if this gets to be onerous. Use variables. What happens if I forget this?
Then it takes everything.
Yeah, it
And
uses,
starts doing like person ID, predicting things, and it's.
yep, everything in the data set goes in the model, and that means that if you didn't specify its role, it's just like a box floating out there, like including person ID. So yeah, then it's a big mess. So if you run your analysis and like the fit is completely terrible and your results section is like way too long, you probably made this mistake. It's very common. So use variables. What we have here, symptoms is going to be my outcome. Women and age are my predictors. Stress is a predictor. Person means stress 40, and then I'm also creating an observed interaction. So in this case, it is a box interaction between 2 observed variables at level 2. So how old you are and what gender you are in a binary measurement over the 5-day period. So this is a daily diary kind of study. Missing data, you want to tell it what your missing data code is. Technically DOT is allowable, but I've run into problems with that, so I don't recommend it. What your ID variable is. Predictor variables that you want to be left only at the level at which you specify. So when I say within equals stress here, that means make my level 1 stress box and don't do anything to it. Just like let it be at level 1. Don't try to find its variance at level 2 because I'm putting that in the model as a level 2 box for person mean stress centered at 0.4. So the between variables then would be age, gender, their interaction, and that. So these are all level 2 boxes essentially. I could have put them in my picture, but I ran out of room. It happens to me a lot. I try to have fewer pages, but then the pages keep getting bigger and bigger and bigger. All right, then we get down into analysis. This is 2-level. Random is what it would be once we add random slopes, but the way that I'm writing it is anticipating it. So I'm adding that in here now, even though it's technically not needed. Regular flavor ML, so that the results will match across R and Stata as well. So then we have the within model. So this is what we would normally have as a multi-level equation, like y equals stuff. That's what you're writing here. Do you remember what happens when you write the name of a variable all by itself at either level? What are you referring to? In terms of the language, if you list the name of a variable all by itself in either level, what are you asking for? Yep, it's either a variance for that variable or a leftover variance if it's being predicted, and it figures out which one it is. So symptoms here, I'm mentioning as I would like the residual variance at level 1 estimated for my symptoms outcome. That is a default, but again, I want my code to be as transparent as possible. Then I am defining what I would call beta 1, having stress predict symptoms at level 1. I have labeled that with the interpretation that it will eventually hold within person X to Y. That's what the path is what we're working on here. This way of building that path, where you name the slope and you define it as a new variable at level 2 in doing so, that allows you to have random slopes if needed, and it also allows you to have cross-level interactions predicting that level 1 effect. So if you want either of those things, then you would have to set up the code this way. In this particular data set, I had actually examined whether we need random slopes for any of these, and the answer was no, so I don't have them in there in the model at the moment. Okay, between model then. If I list the name of a variable all by itself, what am I referring to? The variance. Yeah, but which kind this time? What does between level variance mean?
Level 2 random intercept variance?
Yeah, this is random intercept variance. Yep. I know, right? I want you to remember. I want myself to remember more than that, so I make sure I write out everything. Yep. What about when it's in a bracket? What am I asking for generally?
Mean.
Yeah, means or intercepts. What's the difference? Is that a semantic distinction? Not usually. What's the difference?
Intercept is conditional on the other predictors.
Yeah, intercept is conditional. It's an expected mean when all the predictors predicting it are 0. A mean is just a mean, like in the empty model. So if there's nothing else, then the mean and the intercept are the same thing. So this is the fixed intercept for symptoms. It is not a mean, though, because symptoms is being predicted by this other stuff down here. Let me skip down to what is predicting symptoms. So I wrote these out on 4 separate lines so that I could label what each of these meant and also use labels in here. So in parentheses, these are not constraints, these are labels. I will use some of these in computing the between effect. So I have the main effect of gender, age, their interaction, and then I have the level 2 effect of person mean stressors predicting symptoms. And I have labeled this con x to y. Am I trying to con you? Is that why I called it that? What? Come on, that's funny. I'm trying here. She's like, no, it's not funny. I'm trying. I can say that much. Am I trying to con you? I would not do that. What am I trying to say here? Yeah, and how do I know that this is the contextual effect? How would you know which kind you're going to get at this point in the process? Your choices are between or contextual. And these 3 are labeled as between. This one's labeled as contextual. Because? Want to phone a friend? You got it.
I wouldn't do that to my friends.
Hillary doesn't want to phone a friend and be mean. But what else are friends for? To come to your aid.
Yes, but anyone is welcome to come rescue me.
Okay, anyone is welcome. Stress is also in level 1. There we go. More specifically, what kind of stress at level 1?
All of it.
All of it. That's the key. Okay?
That's where I was trying to go.
Yep. Stress is binary. This is, did a stressor happen to you today, yes or no? And because 0 already means something, I left it alone. But when you put in a level 1 predictor that has all the original variants, the OG version, level 2 has to become contextual. That's how I know. Now, why are these labeled between instead?
Because they can't possibly be within things
Yeah, they can't be within things.
with the way that they're defined.
Right. So we asked them once, how old are you? And that was on the first day. We asked them, what gender do you identify on the first day? And so these are time invariant level 2 people things as they are measured. There is no level 1 analog to it. So they only have between person variance. That's the only kind of effect they can have. So the model is somewhat uneven in this parameterization because we're saying these are the between person effects of age and gender and their interaction, but this is the contextual effect of stress after controlling for whether or not you had a stressor today. What is the incremental effect of being someone who has more stressor days, period, after controlling for whether it's a stressor today or not? That's the difference. We're not controlling for anything with respect to age and gender, because we can't. They're time invariant.
So when you're doing this,
Mhm.
so we're still at the stage manually separating out.
Right.
Okay.
Yep, we're still at the stage of manual separation. So in terms of the picture, let me orient back up here. We're doing this path right here and this path right here from a box to a circle. And that is why I can show you the exact same set of results using univariate software, because we still are predicting one column, which is Y stressors in this analysis. So we're not doing the full mediation model yet. We're building to that though.
So if you didn't want to do the coding beforehand of the partitioning within person or total stress and then person mean stress,
Mhm.
do you have to do that in this?
In this case, it ended up that I needed to because it was binary. So there's no way to put a link function on it if it's not really being predicted by anything. In this version of the code, there is in the single level version. So yes, part of my motivation in setting up the model this way was because it's binary, and I wanted to show like the proper way of using that information. But also, it may not be reasonable for you to have circles for everything. Like some things don't need that. So for instance, if I had age, like if I had time at level 1 and age cohort at level 2, sound familiar? All of you who finished your homework on time? Like if I had something like that, then I don't need to make a circle out of that, right? Like age is perfectly measured if I know when you were born. So I would have like a time box and a cohort box, and I wouldn't need to turn those into circles. I could, but it would be unnecessary. Only in the event of maybe missing data or something would that be a thing I would need to do. So this is a box to circle example so that you have one of those, because that may be a reasonable choice for certain situations. Okay, so then the part we skipped over, these two things right here. Within person X to Y in a bracket, what is that? Because we said things in brackets are means or intercepts, right? It's tricky.
You could think of it like the intercept of the random slope.
Yeah, so if you think of this as a variable now, so the relationship between stress and symptoms could potentially vary across people. Each person gets their own slope in how stress affects symptoms. We're setting up that possibility. Then I've made a new circle that essentially is like a circle for this path. Go back to another picture. Like, instead of calling this change, I would call this how stress predicts symptoms as a second circle. That's the idea. But rather than having time as a level 1 predictor, I have stress predicting symptoms at level 1 instead. Same concept. So yeah, we're creating a new latent variable. Come back. My computer's like, no, you're not. There we go. We're creating a new latent variable. This is its name. What that latent variable represents is one's tendency to have whether or not they had a stressor that day, predict whether or not they have more symptoms than usual that day. That's a new variable. So I'm asking for the variable's mean, which we would call last semester a fixed effect. So this is how stress predicts symptoms at level 1 on average. I've labeled it as such. And then this part right here, what am I shutting off by saying it's at 0? Zoomers, I'm going to call on you this time. What's at 0 mean? Shutting off the variance, yeah. So that means the stress slope is not random in this analysis, it's fixed only. So I didn't technically have to set it up this way because I don't have cross-level interactions yet and I don't have random slope variance. But setting it up this way allows those things to be added to the model in subsequent iterations. Okay, How are we doing so far, folks? Okay enough? Any that you want to hear again or differently? Okay. Then last but not least, how to make it do math. So if you want to make Stata do math on your fixed effects, what do you use? Stata folks. Yeah, not just print it, but actually make the math. Like to figure out, say, what the age slope would be for someone who started the study at 16. Lincom. Okay, our people, what would you do to make that? Figure out who, what the predicted age slope is for someone who started the study at 16.
One test ID.
Yeah, contest 1D goes with the Elmer function. GLHT is another one that I use with a whole bunch of different kinds of models. So you're asking it to do linear combinations of the model fixed effects. Well, M+ has the same thing. Every software package on Earth has this capability. You just have to dig for it. It's something I wish I would have learned way before I did. But we're using model constraint to do so. Model constraint does two different kinds of things. Like its name suggests, it puts in constraints. So for instance, if you have a model that's misbehaving, the variances want to go negative, you can put in a constraint that says, hey, quit it. Keep this variance above 0, and it will go through the estimation with that constraint in place. It also allows you to build new parameters and potentially to put constraints on them if you need to. So I am building a new term that is going to be called BP x to y, meaning I'd like the level 2 between effect, in addition to the contextual effect. And I am building it out of within person x to y. So this term right here is referring to what the fixed slope from x to y at level 1 is eventually going to be. That number will be used right here. Likewise, con x to y is going to give a label to what this level 2 contextual slope is eventually going to be and put it right here. And so then it will sum them, and it will use the delta method to create standard errors for linear combinations, so you don't have to think about that and get a hypothesis test. So now we can get the between effect. Hooray. Okay, want to see what happens? So this will be like a different kind of Where's Waldo task. It'll be like find the number. So here is, for instance, this is Elmer output and output from contest 1D on the right-hand side, or the left-hand side here. First off, where do I find my log likelihood in M+? Yep, you're the hoe. Always remember that. We're the hoe. So minus 704.2, minus 704.2. Huzzah. Where do you find the minus 2 log likelihood in M+? Your calculator. Or M+ automation, if you want to run it through R, I'll probably get that as an object somehow. Yep. Where do you find minus 2 log likelihood in Elmer output? Yeah, do the math, exactly. Yeah, it's right here. So Elmer wins so far. AIC and BIC, you can find those right here as well. Even though log likelihood is bigger is better, these AICs and BICs are in smaller is better. It's like that everywhere because the root of how you make these is minus 2 log likelihood, not log likelihood. So this needs to be big, these need to be small. All right, let's see here. Let's go down to next number that I see, the variance of the intercept. Where's that? Coefficient we're looking for is 0.837. Standard deviation squared, yes. These should match, or correspond at least. If not, then something else is very wrong with Elmer that day. But yeah, this number should show up somewhere on the M+ output. It's residual variance, meaning leftover. Okay, so it's residual variance right here. That is where my intercept variance for symptoms is going to be located. So note the word symptoms doesn't show up in here anywhere. That's because there's the only possibility of predicting the one column. You don't have to make that differentiation. That is your outcome. Whereas you can have intercept variances for lots of things at the same time in a multivariate model. So when it refers to the residual variance of symptoms in the between level, that's the symptom random intercept variance left over after being predicted by age, sex, their interaction, and person mean stressors. How about what it's calling residual? Coefficient is 0.613. Yep, that's this one. So this is level 1 residual variance leftover. So residual in both senses of the word. Yep. It takes a minute to like do the mental rearrangement to figure out what this stuff means. At least it took me more than a minute, so it'll take you just a minute. I had to figure this out by swearing at my computer, so. Yeah, exactly. Oh, I went into my office upstairs and my computer was making this horrible whining noise. And I was like, oh, that's not great. And also, I'm sorry to all my office mates who've been listening to it for I don't even know how long. Like, it's been doing that. So, not good. Tried and true. Break stuff. Let's see here. What's next in the list? Fixed intercept. Coefficient 1.586. This is probably the easiest match. Symptoms intercept, ding, ding, ding. Good job, Zoomers. So this is predicted symptoms for what kind of person? Men. Women are the one group. Who are 80. And who? Yeah, so 80-year-old dudes who had a stressor happen on 2 out of the 4 days, 40% of the time. That's our reference. That kind of person is predicted to say that they have an average of 1.5 symptoms over time. And yes, this probably should be some kind of generalized model, but at some point you just got to like get the example done. Yes?
So how do you interpret the person means stress piece of it?
How would I interpret the conditionality or the slope?
Yeah, the conditionality.
So I'm going with this list of things right here. 1.5 is the expected number of symptoms on average for a dude who's 80, and this is person mean stress, where it's the person mean of a binary variable, so it ranges between 0 and 1. And I centered it at 0.4 because that would mean that they had a stressor on 2 out of the 5 days, 40% of the time. So that was near the mean, but given the interpretation, I figured that that would be a more useful reference point. Since there's only 0, 0.2, 0.4, 0.6, 0.8, and 1 as possibilities. So, yeah. Thank you for the questions. Let's see here. These two. These are relatively straightforward, I think. The main effect of women in age. Yeah, right across, right here. So either way, I could say women report 0.5 symptoms fewer than men on average. Is that right? For an 80-year-old, because of the interaction term. So all the things you learned about that are still in play here because of this interaction right here. What is the interaction doing to the gender effect in older people? Those two. What's the pattern? We haven't done interaction terms in quite a while, have we? I'll bring them back. So women have fewer symptoms reported. 0.5 specifically in 80-year-olds. Yeah, we got a negative main effect and a negative interaction. That's a more negative. Does that mean that the effect of gender is stronger or weaker in older people? Stronger. Yep, more positive or more negative is stronger. Less positive, less negative is weaker. Not paying attention to the p-values, but these both happen to be significant. The age effect is positive. What does the interaction with age do to that, with the age by gender? Yeah, less positive heading into negative territory. Yep. So it looks like there is a slightly positive age slope in men, significant, and it would become a negative age slope in women. Don't know if it's significant. I could find out, though. How could I find out if the age slope were significant in women? Lincom. What do I do to these two numbers to find the age slope in women? And feel free to sing. Hey, it's a throwback. Add 'em up, add 'em up, up. It's a Fall Out Boy reference. It's from like 2 years ago. I decided to start singing in class. But we're going to add them up. Because, yeah, this is the main effect of age. This interaction term says how it differs in women. To get to what it is in women, we add these two numbers together. So I could do that as a Lincom. I could do that as a Contest 1D. Or I could do that by making another one of these kinds of statements and saying add, not that one, hang on, this one and that one together. You can have as many of these as you want. Question?
Yeah, okay, so I thought to tell if there was statistically different, it was the interaction term itself.
Correct. The interaction says if the age slopes differ by gender in this context.
And then to calculate, estimate the slope for women.
Yes.
And then it's when you
Yes, so exactly. So if to get the simple slope of age for women, it's what is the slope of age for men plus how does it differ in women is the interaction term. And then you get what it is for women. Yep. Okay, we're making it. Stressor. Let's find that one. This is a trickier one. Coefficient is 0.110. Yeah, this is here. Very non-intuitive. But this is the mean of the variable that holds the slope, how daily stressors predicts daily symptoms at level 1. Yes. As soon as the words left my face, I was like, you're going to have to say this 4 times for this to make any sense. Okay. The mean of the variable that holds the slope for how level 1 stress predicts level 1 symptoms within persons is that number right there. I think I said it different. I'm trying, though. We called this the fixed level 1 slope last semester. Now we've made that the idea that each person can have their own slope a variable. Like beta 1 could have a fixed effect and a random effect. This is the fixed effect. No?
No.
No? Okay.
But why is it not an intercept? Is it because it's not conditional on anything else? It's not predicted?
Exactly. So this could be labeled as the intercept if this were predicted by some other thing. But it's not, so it's labeled as a mean. It's unconditional. So if you picture the level 2 equation that would go with this, it would be like beta 1 equals gamma 10, and that's it. But we could ask, for instance, what if the effect of daily stressors on symptoms differs by gender? Could we do that? That would be a cross-level interaction. That would then predict this thing, turning it into an intercept. So this mean right here is what we used to call a fixed level 1 slope. It's the average effect, because right now we're not allowing any individual variability around it, but it's still the average effect. There we go. Is this smushed?
I don't even know what it is. I can't tell you if it's smushed.
How can I know from looking at this if this is smushed or not? I got a level 1 predictor here. Stress is going to symptoms. Did I person mean center it? Nope, I just left it alone because 0 is already meaningful, 0, 1. Did I do something else to prevent smushing? Because that's my life's work. I put that on my tombstone.
You have between person stress.
Yep, I have the level 2 analog.
Contextual.
That's right. Because of this right here and that right here, I put in the person mean of stress. That means that after controlling for person mean differences in stress, what's left at level 1 for its unique effect is just the within. So it is indeed unsmushed because I did that manually. What would have happened had I not put that in? It'd be smushed. It's not at all obvious, but it would be. And this would still have the same label. It would just be wrong. So this is the contextual effect right here, right? 1.335, 1.335. This is the within effect. What's my between effect going to be? We can do math in our head, or you can find it on the output, your choice. Yeah, 1.445, where'd you find that? Yeah, new additional parameters. That's the one that we built by adding them up. And here is the contestee equivalent we get as a linear combination. So we're adding the within effect and the contextual effect together to get the between effect. What if reviewer 2 questions my need to unsmush things? Thinks that that's overkill. How do I defend myself? And Lisa told me to is not going to work. Reviewer 2 doesn't give a shit what I think. They want you to stand on your own feet. What about it? Yep, the contextual effect is significant. Another definition of the contextual effect besides level 2 effect after controlling for level 1 is the difference between the two. So another way of saying it is that the between effect of 1.445 down here is significantly more positive by 1.33 than the within effect of 0.11. So the between effect of 1.445 is significantly more positive by 1.335 than the within effect of 0.11. Now, if we look at the p-values here, does it matter if you had a stressor that day in terms of predicting your symptoms? Nope, not according to this, at least not on average. Does it matter if you tend to report more symptoms that or more stressors than other people? Yeah. So for every additional what kind of unit are we in here? This is the effect of person mean stressors, the between person effect, what we're looking at here. Remember what the range was, the possibilities? Out of 5 days, you can have 0 stressors. You can have 1 day, 2 day, 3 day, 4 day, 5 day. So what is the possible range for this variable? Person mean stressors. Its proportion.
I don't know, it's highlighted.
Yeah, it's highlighted. 0 to 1, because this is the mean at level 2 of a binary variable at level 1. So it has to be between 0 and 1. So while 1 unit change is the difference between having no stressor days and all stressor days. So this coefficient is like kind of on a different level and scale and thinking about like the effect of having one more day. I lost. Okay. This is the full range of the variable. So it's not surprising that the coefficient is fairly large. If I wanted to put this into for every additional day on average, what happens? I could divide this by 0.2, for instance. Like, what is the change of going from no days to 1 day to 2 days to 3 days? That would be 0.2, 20% increase. So I could do that if I wanted to put it in a per day metric instead. Let's see. One more I can think of. What about this variance with a test statistic of 999? That looks really significant. Consequence, yeah. Foreshadowing. What is that telling me? Yeah, we forced the variance to 0. So we don't have another line up here where the random slope variance would be because we forced it to 0. So we are saying that how stressors predict symptoms at level 1 is the same for everybody. That the mean of the within person x to y slope factor is 0.11 holds for everyone. There, I think we got them all. So these are treated as z's, by the way, in M+. And so these p-values refer to a z distribution without denominator degrees of freedom. That is why the p-values from R and Stata are a little bit off. For instance, the main effect of women at level 2, the p-value is 0.02, whereas it's 0.018 in M+. Because these are t's and these are z's. Either way, the number in that third column is estimate divided by standard error. It's how you treat it in terms of a reference distribution that matters. So this is one of the reasons why if I don't have a large sample, I might want to stay over here in T-land where I have denominator degrees of freedom and REML at my disposal. I used ML in this case so that everything would match as closely as possible. Okay, questions or comments? Plus 0 instead of just 0, where?
Our code for the contest venue.
That's a great question. It did that. And I don't know why. It's possible that it's a typo that I introduced in making this handout, but it's also possible that that's just what it is. Let's find out. I'm really curious. Okay, I'm going to go into the online files. R and Stata. Come on, you can do it. It's thinking about it. No? Really? No, I can't. I'm sorry, you're asking too much of me. Yeah, I know. My screen is like a metaphor for our brains right now. It's just like I'm trying to refresh, but it's just not going. Okay. Open that in TextPad. Let's see. Okay. Let's find out. Yeah, line wrap. That's why. Mystery solved. It was because this happened in the output. And so when I unwrapped it, it kept the plus in there. So how about I just fix that? And then there'll be no more mystery. There. Problem solved. Okay. So up to this point, there's no reason to use M+ for this. But I'm a big believer in showing you models that you're familiar with software that's unfamiliar, as opposed to starting with unfamiliar models and unfamiliar software all at the same time. That tends not to go well. From this point, we diverge, because now what we're looking at is M predicting Y. So the middle variable of negative mood predicting symptoms. And the question is, should we box it or circle it? You could box it, but it's eventually going to need to be a circle.
Why? Like, I know that that's like what you set up there,
Mhm.
but that's something that I was thinking about, like you have observations for it. Do
So
you have missing stuff?
I don't think there's any missing in this data set, but usually there would
Because
be.
you want to test mediation.
Yes, so we're doing this path right here. That's the next step. And so I could make negative mood into the same kind of box. I could do within contextual or within between. Reasons to make it a circle would be missing data, as you said, so that way we don't throw out the rows that don't have a level 1 observation. Another reason is because this is eventually where we're headed. And so to try and have comparable results in terms of what does M look like predicting Y before we add X in predicting Y also. Like we're trying to get the bivariate relationships at this stage as opposed to the multivariable ones. So, and because I'm eventually going to need it to be latent, I think it makes sense to start with it being latent. But this is the point then where like Elmer and mixed can't do it.
Okay. So, if you were doing this to begin with, like
Mhm.
this is the first time you've ever done this model, you probably don't know where you're going with it, right? Or do you, because of some theoretical sort of thing? I think that's the part that I'm like,
Okay.
why are we even going
Why are we
over
doing this
here?
here?
Where, like,
So,
other than like the example, and that's our class, but like.
yes. Okay, the question is like, what's the picture here? Like, how do I orient myself into this? How would I know where I'm going? I think that it's usually informative, regardless of where you plan to end up, to understand bivariate relationships first. Because where we're going to end up is that at level 1, like, nothing's going to be significant. And the question is there no relationship, say, between mood and symptoms, period? Or is there no relationship anymore after we control for stressors? So I have to have both versions of the model where I have it with the other predictor or without the other predictor to be able to differentiate those things. So I think it's informative, even if you're planning on doing this whole multivariate analysis, to break it into pieces just so that you have a sense of, does X predict Y in the first place? So far, we learned that it does at level 2, but not at level 1. Does M predict Y in the first place? We're going to find that out. And then the question is, does X still predict Y after controlling for M, and vice versa? So to me, I think it's informative to know what each of these looks like in isolation before putting them together to say, okay, what happens after controlling for this other thing? But because I know I'm going to end up there, and potentially having missing data would be another reason, I'm going to make this predictor latent. And so we call this latent centering, which means treat it like an outcome. So conceptually, there's not going to be any difference between what we do in terms of decomposing physical symptoms in between and within. Do the same thing for negative mood. From an estimation point of view, it's just another Y. But we have the choice as to have directed slopes predicting the two or covariances. Up to you. So I have in, let's see here. In this model, I'll zoom in here, I called this step 2A-ish, because it's not the same. Because these are boxes on this side, and these are going to be circles on the right-hand side. And this needs to be red. We'll fix that later. All right. I don't know if we have the strength for a whole nother model, do you?
Wait, is that
They're like,
Fokker?
no.
Is that Fokker?
It's 1:40 by my watch.
Okay.
Yeah, so time flies when you're having fun, right?
Yeah, golly gee.
Fun is a relative term, I think, at this point
It
in
really
life.
is.
Yes, but it can be fun. It's fun when you eventually figure it out. When you can have like that sense of accomplishment, and it's even funner when your hypothesis is supported after you figure it out. That's the win, right? Dare to dream. I'm not judging your projects based on significance, though. If you find a big pile of nothing and you do a great job at it, you get all your points. Because that's not your fault. But it would be, I think, instructive for your peers to hear what all you tried in that case. And they may have further ideas on how you can salvage your thing. One approach that I would recommend is to turn it into a tutorial. If you figure out a very complicated method that is not often used in your field, even if your results don't contribute theoretically, you could use them in some kind of didactic piece to explain how to do these models, and you could even volunteer your data if it doesn't have any value because it didn't find anything. And that is how you turn your master's thesis into an unpublishable piece of crap into something useful, hypothetically speaking. That's one of my most highly cited papers, is a failed master's thesis that I turned into a multi-level modeling tutorial. Problem solved. So, even dead results can eventually find a home if you're willing to be creative. All right, questions or comments before we adjourn for the day? Question? Zoomers can question too. No, I'm just letting them.
Well, okay, so if we don't have, if there's missing data on a predictor,
If we have missing data on a predictor, then what? Is that the question?
yeah,
You have two choices. You drop that case because your predictor is not in the likelihood, it's a conditional likelihood, or you say, I'm just going to pretend it's an outcome and keep as many cases as possible, and then you invoke distributional assumptions for your predictor.
how does that actually work? Like, what's the code
The code
for that?
for that is right here, actually, because what we're doing is we're saying mood 2 is my variable. It's a predictor. It's not being predicted. But in asking for this, that's its fixed intercept. This is going to be its random intercept variance. We are essentially predicting mood with an empty model as a second outcome.
And you don't hold anything to 0 or 1.
At this point, no. What would we have to hold to 0 or 1?
I just found an example yesterday, and it held something to 0 or 1, and it wrecked everything. It was very odd. I didn't.
Okay. Well, if you want to send it to me, I can try to take a look. But the difference is that this, when you're listing this variable, this is the x circle at level 2, or not x, m in the middle. It's x with respect to this prediction, but yes. So this is intercept variance in mood. That's creating that middle m circle. Whereas down here, we're setting a slope variance to 0 instead, not a variable variance. So this is a random slope being shut off. This is a random intercept being turned on. So the short answer to your question is, to have predictors that have missing data, we turn them into outcomes. Then we can use incomplete cases, but we have to have distributional assumptions. And so that's what I was unwilling to do with respect to stress, because I knew it was binary, and I couldn't do that the proper way until like 5 pages from now, of course. Okay, other questions? Zoomers or roomers? Trying to make eye contact with everyone simultaneously. A little tricky. I know. All right, then 144. Thanks for being here. Hope to see you again Thursday for more fun with this. Let me know if you need anything. Keep working on your project outline revisions as needed. Okay, peace out, everyone.